Hi everyone, I'm Caio Viturino, and in this video I'm going to show you a palletizing simulation in Omniverse Isaac Scene. Actually, I want to give you a high-level overview of how this is working with integration with ROS2. As I said, I'm Caio Viturino. I'm a PhD in electrical engineering, specifically in robotics and artificial intelligence. If you are interested in this simulation and other simulations in Omniverse Isaac Scene, please don't hesitate to contact me in LinkedIn. Yeah, in this simulation, I have a ROS2 action server that's generating a trajectory for the UR5 in the simulation. In this implementation, we have 5 types of trajectories that are already implemented. If you want to check out how this is working, please see my last video about UR5 inverse kinematics. And also we have a ROS2 action client. I forgot to add a C after this A, but whatever. In this client is communicating with the Isaac scene control. Okay, in this action graph, we have some nodes to read the position of the boxes because I need to know where they are in order to grasp it. In this simulation, I don't have a grasp generator algorithm using AI or neither a object segmentation model. I just get the position and the orientation of the boxes in simulation, and then I use as input to the inverse kinematics and then to the trajectory generation. In this action graph, the most important thing is the customized node, this UR5 pick. This node is responsible for creating the ROS2 subscriber and ROS2 publisher. And this is how I publish the box position and orientation to the ROS2 action client. And this client will send the position of the end effector to the trajectory generation server in order to generate the position, velocity, and accelerations to the robot to follow. Okay, and we also have the Isaac scene articulation control that are available in the documentation, official Omniverse documentation if you want to create it. And in the following videos, I'm going to describe in more detail of how this work. But in this moment, I just want to show you how this work. And in this simulation, I won't make it available yet, but if you are interested, please contact me. We have the scene command action graph. Like I said before, this action graph is responsible for connecting the simulation with the external ROS2 action client. Okay. We want to set up the simulation as fast as we can because we don't want to waste time figuring out how to set up the simulation, to control the robot in the simulation, etc. We want to use the simulation as a plug and play tool or something like that. That's why in this action graph, I'm connecting the ROS2 using the subscriber and publisher to the simulation. And I won't show the code in detail, but we have here an extension, ROS Omniverse extension, like this one. This is for the customized node that connect the ROS the Omniverse action graph to the ROS2. Here I create the publishers, the subscribers that publish the box position orientation to the action client or the scene controller. Okay. And basically that's it. We have infinite possibilities to improve this simulation. We can build a complete warehouse simulation with these features, and it is pretty straightforward to do with these action graph nodes. So yeah, I'm very happy with this new Omniverse 2, and it opens many possibilities for us robotics developers to play with the simulation. And that's it. And like I said, if you want to know more about it, please contact me and I'll be happy to talk to you. Okay, see you. Bye bye.